keynote speaker is on how to deliver the fresh, real-time maps that are needed to power the next generation of driver assistance and autonomous mobility services. How can we use artificial intelligence in a more efficient and cost-effective way? Our speaker is João Barros, a full professor at the Department of Electrical and Computer Engineering at the School of Engineering of the University of Porto, Portugal, and the head of the Institute of Telecommunications in Porto. Since 2008, he's also a visiting professor at MIT. Please help me in welcoming João Barros.
Thank you so much. Oh, what a pleasure, and what a room. Thank you for having me.
It's a beautiful room, isn't it? So I leave the stage for you, and then, like previous keynotes, we probably will have a few questions.
Perfect.
I'll be here.
Thank you so much. I appreciate it. Good afternoon, everyone, and thank you so much for coming. It's a true pleasure to be here. And I know exactly what you're thinking. Not another talk about AI, but I'm not going to be talking about ChatGPT or generative AI. Actually, I'm going to show you how the latest algorithms combined with the latest intelligent cameras can actually finally deliver one of the long-standing dreams of everyone in transportation or urban planning, which is a real-time map of our streets, our roads, our cities, in a way that preserves privacy and security, but yields also many, many insights for many different applications. And so AI is truly hitting the streets in a very practical way. And if you look at the next slide, you're going to realize that, and actually I just reminded me, I am the next slide. So pushing over here, today, when you look at vehicles, they're actually not yet that smart. Most vehicles are disconnected, they have limited computing power, all the different electronic control units are separate from each other, and they have very small batteries. Now, this is changing pretty fast. Tesla showed the way, and now every automaker is aware that consumers are demanding more and more digital features, so they put more computational power. The ECUs are now centralized. The car actually has a brain, and it's like a smartphone on wheels. Essentially, it's connecting all of these systems and getting all of this data. And they have larger batteries, which allow us also to do a lot more things in terms of digital computation. And so the additional new feature that they have is they're coming with more and more cameras. The company in which I worked until September, Nexar, has these dash cams that both consumers and also commercial fleets are putting in hundreds of thousands of vehicles. And the application is quite simple. They have a camera that faces outwardly to see the street and a camera that faces inwardly to see what's happening inside of the cockpit. And when there's a risky situation, they signal it, and when an accident happens, they are able to upload the video to the cloud. And with AI, you're actually able, just based on the video and the sensor data, to produce a very accurate report, very fast, of what happened in the accident. So this reduces the time it takes to actually process claims. Now, the beauty of it is that once you have cameras in vehicle, you can do a lot more. And so today, we're actually able to see 94% of US roads at least once per month, and many of them actually much more frequently. For example, in New York, there are about 4,000 Uber vehicles that have the camera I just showed before, and they're actually able to have enough enough density and enough frequency to be able to see free parking spots. That's how much visibility we get in real time. And this means that actually these cameras are doing about 50 million detections per day of objects, street signs, traffic lights, road construction, potholes, all of these different things, and collecting more than 3 billion miles of videos and images per year. And so that means that now we can actually map the world in real time using moving cameras that happen to be in vehicles. And we do that by crowdsourcing these videos and images from millions and millions of vehicles. So obviously, there's the safety application, but what we're also really excited about is being able to do a digital twin of our roads, so essentially being able to recreate what is happening in various domains, both the vehicles and traffic, as usual, but also the infrastructure and everything that matters to have a safe, sustainable, smarter city. Now, I would like to show you the platform at work. So my role was Chief Platform Officer, so I was responsible for actually the strategy and the building out of this. And as you can see here in the map, when you go on the platform, you see a map of the United States. And all these beacons are objects that are being detected in real time. And we have different classes of detections. So the orange ones are work zones. So we detect drums, grabber cones, etc. Then you have road inventory in blue, where basically all the different street signs and some that are more important than others. For example, right now, speed limits are really, really important because no digital map actually has 100% accurate speed limits. So it's really important to get those speed signs for automated driving and for intelligent speed assist. And then road conditions like manholes, potholes, damaged roads. This is also important for automated driving and autonomous vehicles because you want to avoid those types of things, and also for drivers, of course. Now, once you click on one of those detections, you actually get a picture that is anonymized. So as you can see, all of the license plates are gone, and you're actually able to see the detection that you made. So once you aggregate all of these data from these different vehicles, you can have very accurate maps. And so, for example, the city of Los Angeles uses this service to see if anything changed regarding the traffic signs. So there's vandalism, there's bad weather, so they can check how their signs are doing. And there's a kind of a Google Street View on steroids, which is you can click any one of these hexagons, and basically, once you click the location, you're able to see all of the pictures that we've been able to collect from all of the vehicles that passed through that location. And so then you can choose, and you can see during the day, during the night. You can compare if there was, a flood or any other kind of catastrophe. You can actually compare the before and after. So this is not science fiction. So it's working, and it's being used by a variety of customers, both on the mapping side, cities, as I mentioned before, and more applications are coming up. For example, work zone monitoring, knowing when work started, when work ended, to make sure that the work zones have permits and are complying with whatever rules you have for that type of construction. Now, when we compared, what traditional maps had so far and what the real-time mapping platform is able to get, we see, for example, that OpenStreetMaps, which is very popular because it's free, 53% of our detections actually did not exist in OpenStreetMaps, or they existed and had changed. And so this is very significant when also there's regulations that depend on the accuracy of these maps. We can also say, scientifically, how much are we able to cover in 10, 20, 1 hour, 2 hours? So that gives you a sense of the sampling rate, or at what speed or what frequency we're able to actually get data from different locations in different parts of the city. Now, Coming from the business side and from the industry side, you obviously need to be able to have a solid business model that generates revenue that you can reinvest in building out the platform. And so the way that this works right now is that actually you go to a customer and you say you have different modalities. So you can have detections, you can have just change detection, so just what change, images, training videos. You can have different types of objects and different types of detections, different time frames, location, and what interface you want, whether through an API or whether you want to use the UI or just get a data set. And then, based on the value that these types of data and these types of modalities have for you, then the pricing is adjusted accordingly. And so essentially, we're not building maps. It doesn't start by mapping. It starts with a base map, but then we add layers on top of it, and different applications have different requirements. So for parking, as I mentioned before, you require very high frequency, so you have to be able to see a location like every minute or so. But for example, for traffic signs, nobody wants to receive 1,000 pictures of the same stop sign, every hour. So you can vary depending on the object of interest and make your platform adaptive to be able to sample it with the right frequency. The holy grail is actually to have behavioral maps. So you're actually able to monitor how drivers react to different traffic situations and different, basically street designs, different contexts, and weather it also plays a big part in that, as we all know. And the beauty is that once you have a huge data set of that, obviously anonymized, you actually have the equivalent of a data set to train a large language model like ChatGPT that basically takes, tons and tons of human text. Now you have tons and tons of human driving data. And so instead of having a rules-based driver assistant or a rules-based autonomous vehicle, you can actually now learn from the humans at a much, much, much bigger scale, and then train your AI models to drive in a safe way based on those examples. And typically you'll end up with some hybrid between rules and human behavior. Now, how do you then expand this to cover, the entire world and be able to actually have a real-time mapping of all the streets and the roads? Well, you need more eyes on the road, so you need more cameras, more vehicles. That gets you more coverage. That gets you better data, better apps and services, and that again generates more demand for the data because the data is higher quality, and you get into this wheel that basically keeps flywheel that keeps going and going and growing until you're able to actually cover the entire area. So that's the strategy. This is a complicated slide, but just to show you the basic idea, on the left-hand side, you have cameras that are proprietary, you have other dash cams, you have vehicle cameras over here, and different types of fleets, different types of vehicles, so consumer fleets, mobility as a service, so Uber, Lyft, etc., auto OEMs, autonomous vehicles. And these cameras have a software development kit that is actually running AI at the edge. And so this is really important because the cost of processing all this data at the cloud is prohibitive. So the idea that we would upload all of the images and then run the AI models in the cloud is just not going to work. So this is one of the key innovations, is actually moving the intelligence to the edge, to the devices, and it's one of the most striking examples of edge AI that I have seen so far. And then basically this you select at the vehicle, what data is relevant, and also with which images are relevant. And then with the technology of my previous startup, Venium, you're able to make an intelligent selection of which network to use. So the cellular network, the Wi-Fi network, or even the vehicle-to-vehicle communication network, to then be able to upload the images through the most affordable network for the purpose that you need. And again, sometimes you can wait, sometimes you need to send immediately, like the position of the vehicle. If it's a taxi, you need the position of the vehicle, instantly, so that people know when the taxi is arriving. But an image, again, from a work zone may wait a few minutes. An image from a traffic sign may actually wait a full day. So no problem about that. And then you feed the data from the cloud through these different, in different ways, in different formats, through APIs or user interface back to the applications and services, and it goes back. And you can have an incentive system here so that more and more people join the network to basically generate more and more data and better maps for their user experience. And so the software development kit, for those of you who are more technically inclined, basically has these modules, the smart connectivity that we developed at Venium, and then the vision AI that basically means that you need to have the expertise to write embedded software that is able to run these deep neural networks very efficiently with limiting processing and limited memory and storage at the edge. You have the safety applications, I mentioned before, fleet services, so this is more standard, so there are many solutions for that. And then the data library, and the anonymization is really important. So you also need AI to be able to erase people from the pictures, or at least make them unrecognizable, erase license plates, the dashboard of the vehicle. We'll see some examples. Okay? So the beauty is that once you're doing all these detections at the edge in real time, now you have full context awareness, and you can increase safety and map the world at the same time. And so to be GDPR compliant and also in general, just to be ethical, you have to invest also quite a lot in technology that makes sure that there's practically no recognizable data in the images that you are uploading. Okay, so what is the challenge? When you're doing different levels of automation, the vehicles are the algorithms are very data hungry, and we know that especially the last few percentage of safety in autonomous vehicles and driver automation are really hard to get. And so today, actually, when you look at how much machine learning is used or was used until now to develop those algorithms, it's very much in the beginning at the sensor input for perception and prediction, but then after that, it's essentially rules-based. So you have a planner, and you execute those rules, and you try to infer what is the context, and then follow those rules. So we've hit a bit of a ceiling in terms of how much better systems that operate under this, in this way can actually achieve. And I was asked to leave some time for questions, so I will just present a few examples of this. So the solution we proposed is to use crowdsourcing, and crowdsourcing basically, since so many of these vehicles have cameras, allows you to get lower quality images and lower quality videos, but in much greater quantity. And what we've been able to show is that that really makes a difference. There's a minimum quality that the videos and the images have to have, but having a lot of them truly has. And so you collect corner cases with vision and with other types of sensors, and then when you combine all that with the map, now you're able to have all these different situations really well characterized for your development. So I won't go into the details of how to do the sensor fusion for that. Just wanted to show you one last example, which is when you have lots and lots of 2D images from different angles and different positions, and they are geo-referenced, it's actually possible to build high-definition 3D maps. And this is actually quite surprising, but it requires a bit of computation. But we actually compared our 3D reconstructions with low-quality images to LiDAR, which is, the golden standard to be able to do that. And it turns out that we get similar accuracy to LiDAR by combining all of these pictures. So finally, we're able to get the cost of doing real-time mapping down by not needing anymore to invest a lot in mapping vehicles, dedicated vehicles, and fuel and driver costs. So the data is collected while people are doing other things. You save on data transfer because now you're doing AI at the edge and you're making smart decisions about which network to use. And finally, you have cloud computing and storage to be able to do the final data processing, but you don't require to process all of the data, just a tiny fraction of the data to be able to achieve that. And last but not least, by doing the fusion of all this data, we're also reducing the need for manual annotation. So the future, I believe, is going to be that vehicles coming out of the factory with a lot of cameras, we have to use it responsibly, but we now have commodity AI models that can be used at the edge with the devices, and we can manage the costs in such a way that we can actually make real-time mapping a reality for all those different applications that we saw in the example. Thank you very much.
Thank you. And let's move over to this table, and
Sure.
I will bring my questions from all of you.
And there are no cocktails? It's just...
At this time of the day in Sweden, we usually have water. So I think a transportation system is like any system, so some of these questions can then be translated into real-time opportunities in any system. So I think they're very relevant. One is about trust. How can people be sure that the system does what it says and it does what it's supposed to do?
So it's verifiable in that, and the systems are auditable in that you can actually go see what data is being collected and verify and that the image is anonymized as it's supposed to be. Also, when you sign the terms of use, it explains to the user, what is going to happen, what kind of data is being collected, what is going to happen with that data. So that's really, really important as well for people to be able to trust the system.
And over time?
And over time, I think what people then weigh is, what are the societal benefits of having these systems? Is it worth it? And if you're able to indeed avoid accidents, accelerate automation and autonomous vehicles, I mean, my dream is, and the dream of many people, is actually to have a mobility system that requires 10 times less cars because they're shared, they're electrical, they're connected.
They can drive really close to each other.
And much safer because these systems are already provably much, much safer than the regular, the usual human driver. And personally, I much prefer to be doing other things than to be sitting in a traffic jam driving my car. So that's what we're trying to enable with this technology.
Because there are some questions here about consent. How do the participants consent for the mapping, and what are the limits of the detection? Do they send images even from their private garage? Runway, or what does it? So, and this question of privacy is an important one.
So the garage, for example, is not going to show up because the algorithm, there's nothing in the garage that is captured by the AI models. So the AI models are looking for things that are relevant for the city infrastructure in terms of traffic signs, work zones. I showed the example. We're getting also requests for foliage is another one that cities want to see whether a tree is covering, important sign. Another example is floods. There's actually possible with AI models to detect not just if the road is wet, but actually how much water is on the road. And so the use cases are all about the streets and the roads, not so much about housing or apartment buildings or things like that. And then again, the dashboard, everything inside of the vehicle it has to be protected. And some things are tricky. You have to train even the reflection of things on the windshield. You have to train to eliminate those.
And you said you were also using the inward camera. What's the inward camera used for?
So actually, there are two use cases, especially in the United States, why people are buying dash cams that are very prevalent, particularly consumers. One is parents with teenage children that are driving. And so they want to make sure that their children are safe. And so you are detecting, for example, if someone is holding the smartphone and driving at the same time. And then it's
Does your system do that?
So with the internal camera, you're able to see these behaviors. You're able to see, for a fleet driver, if someone is falling asleep. So there's a real reason why it makes sense to have that camera. But that part of the information is processed locally, so it's not sent to the.
Yeah, can you just describe that for us? Because you said this is a great example of AI models at the edge, and at the edge means that the data is processed locally and not sent back over the cloud or to a central. And why is that so important? And what are other applications that we need this for?
Well, you just mentioned the privacy preservation. If the data is in the cloud and can be subject to attacks and so on, then you're less secure than you are if the data is just processed locally and only anonymized data in a small fraction of it is sent to the cloud. So that's one reason. The other one is latency. So you're able to react much faster. If I had to, for example, based on the image, to, let's say, detect a risky situation, if I had to send the data to the cloud, have it processed there, I would be at least at 250 milliseconds, and 250 milliseconds, the car already crashed, right? So all these applications that require real-time reaction, having AI running at the edge is really good. The other thing is that we're actually right now quite limited in the computing resources in the cloud itself. There's a GPU shortage. Eventually, the market will probably regulate it, but there's also materials that are needed that are scarce, and so we're making the most out of all the devices that are at the edge, and also our smartphones. To give you another example, for medical applications, now you can actually put, an AI doctor or an AI teacher or tutor in a smartphone. It can operate without connectivity in places like Africa or Latin America, where you have less connectivity. So those are examples of AI at the edge that is able to survive in an environment where you don't necessarily have unlimited access to a cloud or very fast, high bandwidth communications.
There is a question here about trust again, I think, because the question is, has there been an interest in the images from government law enforcement agencies? And I detect a worry underneath that. If I subscribe to this service or any other service that starts out in one way, how do I know over time that others don't buy this data or use this data? So
just in general, all companies that have digital information are required by law, if there is a mandate, to provide data. The way that liberal democracies protect against that is that you have a judicial system that where a judge has to issue a warrant or at least approve a warrant for the company to be compelled to do that. There we either trust, the judicial system, or we don't. If we don't, then we are in serious trouble. But essentially, companies, what we are compelled to do with GDPR and just in general is to inform people of what data we are collecting, what are the uses, and then minimizing the amount of data. And there's also an economic incentive to minimize the amount of data because it's expensive to transfer data from moving vehicles to the cloud. And
the application CityStream, there's also a question, is it a publicly available application?
Yes, you can go to citystream.getnexar.com. It's the URL, and you can actually, there's a playground, so you can register for free and get access to a demo version where you see the big picture of the US, but you can also actually go all the way as deep as you want into New York City. And then if you're interested in other areas, you can then talk with the sales team about it. For researchers, there's also a program for universities, and you can find me online, and I'm happy to send you to the right people.
A final question. The theme of our conference is collaboration and conflict, and this kind of service that or application that you just demoed needs a lot of collaboration.
Yes.
Tell us what has fueled collaboration here and who you see joining sort of in the future to collaborate even further.
So the vast majority of the cameras that deliver this data are consumers. So it's people like you and me who buy these dash cams, and mostly because of the immediate services they have. But then you feed back also the benefits of having real-time maps in terms of features that they're able to have because they're contributing with data, and that's how you incentivize collaboration for the consumers. For the fleets and for the automakers, it's actually more difficult to federate them because they're competing against each other, and they actually are even more demanding in terms of data privacy and data security.
And how do you incentivize them?
And so the way there is that you separate data that can differentiate your vehicle from common data that is useful for everybody. For example, the location of a certain accident in real time is useful for everybody. So this is information that everybody can share. The specific route that the DHL delivery van is taking versus the FedEx delivery van, that's competing information. It's also privacy issues, and so we don't share that.
Thank you so much for joining us, and you will be around during the day, and I'm sure you will have more questions. Thank you so much.
I look forward to that.